Okay, now after we've been talking about polynomials for some time in class, I want to talk about how these polynomials begin to come to play in numerous science and engineering problems. And that the solution to differential equations, and in fact some complicated differential equations, involves the use of something called uh, partial fraction expansions. So that's what I want to talk about now, are partial fraction expansions. Now, when we have a fraction as a numerator and a denominator, as shown right here, a fraction written with a polynomial in the numerator and another polynomial in the denominator. And I'll call this fraction f of s. So here's our fraction, and instead of using the variable x as we've used in the past, I'm using the variable s. Now the reason for that is because when you do Laplace transforms, you use the variable s. So while we will not be doing Laplace transforms, I will use the variable s. So if some of you at some point in the future see Laplace transforms, there will be some familiarity here because we're using the variable s. Okay, so here is our fraction, s plus 3 in the numerator, and it's divided by s cubed plus 7s squared plus 10s. Okay? Now, what is the partial fraction expansion? Let me go through this. First thing we do is we factor the denominator of this fraction. Okay, and the denominator is this s cubed plus 7s squared plus 10s. So when I factor this term right in here, it becomes s times the factor s plus 2 times the factor s plus 3. Okay, so try that. Remember, let's do this. Let me write this here. If I have s cubed plus 7s squared plus 10s, I can factor out the s right away and write this as s times s squared plus 7s plus 10, and s squared plus 7s plus 10 I can write as s plus 5 times s plus 2, and then let me not forget to bring down that s. So this is how we factor that denominator. Now, with partial fraction expansions, what we're going to try to do is take this expression right in here and write it in this form, okay? This form right here, where we write it as a1 divided by s plus a2 divided by s plus 2 plus a3 divided by s plus 5. So here notice that the factors are s plus 2, and s plus 5. So we try to take this polynomial divided by a polynomial and write it as a1 divided by s plus a2 divided by s plus 2 plus a3 divided by s plus 5. So the problem is to find these coefficients a1, a2, and a3. So how do I do that? I do that as I show right here in this expression. So I'm going to take my fraction f of s, and I want to find the coefficient a1. The way I find the coefficient a1 is as follows. I notice that I have a1 divided by s, a1 divided by s. So I take s, multiply it by f of s. That can be written as s, and here is f of s right here, this expression. So this is s times f of s. Now if I write that expression in this form, it equals s times a1, it equals s times f of s here can be written as s times a1 over s plus a2 over s plus 2 plus a3 over s plus 3. And now I bring this inside, multiply each term individually, and I get what I have right here. I get s times a1 over s. I get s times a2 divided by s plus 2. See that right here, a2 divided by s plus 2 times s. And I get s times a3 divided by s plus 3. That's right here. Okay, so let me multiply this through. S times a1 divided by s is just a1. Then s times this is unchanged, and s times this is unchanged. Now what I do, okay, now I've multiplied s times f of s, and I notice, when does this denominator term equal 0? This denominator term equals 0 when s equals 0. So I take s times f of s, that's this, and I evaluate it at s equals 0. So if I do that, evaluate this whole expression here, when s is equal to 0, I get 0 times a2 divided by 2, and 0 times, this should be a3 divided by 5. Okay? So, doing that, I find that on the left-hand side, I get 3 divided by 2 times 5 is 10. So I get 10 is equal to, and that's equal to 0.3, and that's equal to a1, because all the other terms are equal to 0. So that is how I solve for a1. Now, how would I solve for a2? Let me do that. Let me delete all of this right here. Oh, didn't want to do that. Okay, how do I solve for a2? Well, I look at f of s, and I'm going to multiply by the denominator here with the term a2, and the denominator is s plus 2. So in order to do this, I do s plus 2 times f of s. Okay, so s plus 2 times f of s is equal to s plus 3 all divided by s times s plus 5. Now if I write out the fractional form here, this becomes s plus 2 times a1 divided by s plus a2 divided by s plus 2 plus a3 divided by s plus 5. Okay, so I have s plus 3 divided by s times s plus 5. Here, this gives me s plus 2 divided by s times a1 plus a2 plus s plus 2 divided by s plus 5 times a3. And now I'm going to evaluate where does s plus 2 equal 0? S plus 2 equals 0 when s is equal to negative 2. So I'm going to take this whole thing right here and I'm evaluate it at s equal to negative 2. If I do that, on the left-hand side, I get negative 2 plus 3 is 1. So I get 1 divided by, I get negative 2, and then negative 2 plus 5 is 3. So negative 2 times 3 is negative 6. So I get 1 over negative 6 equals, s equals negative 2 this term equals 0, that's 0. A2, I have 0 plus A2. Let me write it like that, 0 plus A2. And then over here, S equal negative 2, and this term is 0. So I get 0. So I get A2 is negative 1 over 6. Okay, now finally we want to evaluate for A3. So let me do that. Let me delete all this thing right in here. Okay, so again, A2 is equal to negative 6. Okay, to find for A3, I take this expression here, multiply by S plus 5, and then evaluate it at S equal negative 5. So let me write that out here. I get S plus 5 times S plus 3 divided by S times S plus 2 times S plus 5. And of course, the S plus 5's cancel here. And this is equal to S plus 5 divided by S times A1 plus A2 times S plus 5 divided by S plus 2 plus S plus 5 divided by S plus 5, which just gives me A3 here. Now I evaluate everything here at S equal negative 5. Okay, that's because that's where S plus 5 is 0. Okay, so I get S plus 3, negative 5. This is negative 2 in the numerator. Negative 5 times negative 5 plus 2 is negative 3. That's what I have on the left-hand side. This is equal. S is equal to negative 5. This is 0. S is equal to negative 5. This is 0. So I have A3 is equal to this. This is negative 2 divided by 15. So negative 2/15 is A3. Here's A2. Here's A1. Okay, so that's how we find an example of how we find the coefficients in partial fraction expansion. Until next time.